And now we'll talk about the circular convolution. You can do circular convolution of any length sequence, but to make it a little bit theoretically clearer before we move on to the more complicated case, I'll say of two sequences that are both of length n. And before we do that, let me just go back in time and talk about doing the math of just plain old regular convolution, which is, this is what we want. We like regular convolution. And the math for regular convolution is that x of n convolved with h of n is equal to the sum from k equals 0 all the way up to n minus 1 of x of k times h of n minus k. So this represents, the regular convolution represents our output y of n. And for every sample y of n, for y of n equals 0, we're going to have to do the summation. And then for y of n equals 1, we're going to have to do another summation. And for y of n equals 2, we'll have to do another summation. So this summation is not a summation we do once. It's one that we do capital N times. And every time we do that summation, it's the summation of n different values. So we're doing a total of order n squared multiplications and additions total. And how long is the result of this? For us, if our x of n is of length n, capital N, and if our h of n is also happens to be the same length, then how long will our result be?
Capital length of n.
No. Do you remember how to, do you remember anyone else from when we covered how to do
the two lengths added together minus 1, sir?
That's it. That's it. And since these lengths are the same, it'll be 2n minus 1. And for us, just to make this clear in scrap paper, on scrap paper over here, let's say that this is x of n, and let's say we're convolving it with the exact same h of n. Remember, our first step is we're going to flip h of n. And now, to find y of 0, we'll multiply these two together. And when we multiply this guy with this guy, here's our x, here's our h, here's our flipped h. When we multiply them together, there's only one non-zero, there's only one place where they overlap right here, and that's right in the middle. But if we want to find out what y of 1 is, we're going to shift this to the right by 1. And now when we overlay them, we'll see that they overlay both at the k equals 0 and the k equals 1 position. So it's going to look like the sum of these two things, which will be equal to 2. And then to find out what y of 2 is, we'll have to shift this further to the right. And now when we multiply this with this, they only overlap at this position. And then if we push it still further to the right, we see that there's no overlap at all. This doesn't overlap with this, so when we multiply our x of k by our h of 3 minus k, our x of k times our h of 3 minus k, we see that there's no overlap at all, and so this will be 0 and so on. So our whole y of n looks like 1, 2, 1, and everything else is zeros. And so this is of length 1, 2, 3. And that goes along with what we said over here, that n length of 2 convolved the length of 2 would give us a length of 3. Okay. Questions on that quick review?
Sir, would you...
Shoot.
Wait, you said review. Have we done this before?
Yes, this is just regular convolution.
Oh, okay. All right.
Nothing new here.